Okay guys, so we're just going to have a look at basic trig really for some right angled triangles. So, what's it all about? There's a triangle. So, if we had just one angle, let's say one side, I'll go with 4 meters. Now, we know about Pythagoras' theory, and that tells you that that square plus that square equals that square. But we're not really going to be able to use that because we've only got one side, and for Pythagoras you need 2 sides and we can get the third. So we need more, much more than that. In this case we've got one angle and one side, and from there, using the 3 trig equations, we can complete this triangle. Now, it's, you know, we could actually complete the angles already because all the angles on a triangle are going to add up to 180 degrees. So just using a bit of logic and knowing that that's a 90-degree angle, you know, we can kind of calculate the rest. So in this case, this is 90, and this angle must be 54. But what about the sides? Well, that's what the trig equations come into play. So you will have heard of, hopefully, SOHCAHTOA. Now, there are more amusing ways to remember that, but I keep getting told not to say them, so I won't. And what they mean is a prompt for this. So sine of the angle is equal to the opposite over the hypotenuse. And the cos of the angle is equal to the adjacent over the hypotenuse. Just going to shorten it to height. And the tangent of the angle is equal to the opposite, just going to shorten it to op, over the adjacent. Shorten that. So first off, you know, these strange names, hypotenuse. Well, the hypotenuse is always the slopey side, and it's the longest side of a right angled triangle. It's always that one. It never changes. That's the first thing to know. The adjacent and the opposite, well, they do change depending on what angle we're talking about. So let's just say we didn't have that and we've only got this one. So to work with this angle on these equations, we would have to label like this. So what I tell my students to do is turn that into a little eyeball. Now, opposite the eyeball is there, and next to the eyeball, or adjacent means next to, is here. So from that we can kind of fill in what we know here and then decide which equation works, because we're allowed to use any of them. It just depends on what we've got and what we haven't got. Obviously, like any equation, we need 2 of these to get the third. In any combination we can transpose for all of these. And the other thing to understand is that it doesn't, you know, if you're just using it for this, you don't need to know what sine, cos and tan is. The truth is, they're very complicated functions. There's no standard for them, how a calculator works, as I discovered recently. And they all kind of use different algorithms. But the point is, we're very lucky because we've got a button for it. So all we have to do to use this is press that sine button and then put the angle in. So in this case 36. And then that is that side. So if I press equals, I'll get a number. So there we go. If I want to convert these to numbers, if that makes it kind of easier in your head, then we can do that. But just know that with trig, you kind of need all of these to get it as accurate as possible. Otherwise the accuracy does waver a little bit. But just to kind of illustrate the point, you know, I could say this is 0.59 cos of 36 is 0.8. That's a typical power factor, that is 0.81. And then the tan of 36, that's 0.72. So I mean, what I'm saying is, you know, we can get a number for that, and so then it turns these equations into some very easy equations. Actually, it's a number is equal to something divided by something. Simples. So don't, you know, get bogged down with, oh my god, I don't understand that, that's very alien to me. It doesn't matter. It's something divided by something equals something. Just look at it like that and it seems to work. But let's go through solving this. So I'll just redraw it so it's a bit clearer. So we've got 36 degrees there. We know that. Like I said, we know that this is our opposite, that's our adjacent, and that's our height. So out of these equations, what can we use? Well, we've got the adjacent, we haven't got the height, we haven't got the opposite. We've got all of these because we're working from this angle. So we can use tan to get the opposite, and we can use cos to get the hypotenuse. There's no rules here, we just decide which one we want to use first. So, you know, let's use cos to get our hypotenuse. So it says cos of the angle, which for us is 36, is equal to the adjacent, which is 4 meters, divided by the hypotenuse. And then transposition, it works the same. Just treat that as one thing. Like we proved, it's just a number. So to transpose for the hypotenuse, you'd have to do the opposite function by itself. Copy it this side. And then we can cancel because height divided by height is 1. And then we'd end up here. But we want height, so we'd need to divide out that. Copy it this side. And then cancel. And so our equation then is the hypotenuse is equal to 4 divided by cos 36. So let's see what we get. So 4 divided by cos 36, 4.94 meters. So we can draw that in now. 94, Craig. So there we go. So let's go back to what we had earlier, just the 4 meters and the angle. And this time we'll use tan to work out this opposite. And that just shows that you could have done either. And then once we've got the opposite, we'll just check all these sides in Pythagoras, just see how close we are. Okay, so the tan of the angle, which in this case is 36, is equal to the opposite, which we don't know, divided by the adjacent, which we do know. To transpose for that, it's a bit simpler really. We just do the opposite function by itself, multiply out 4 meters, copy it that side, cancel it the first side, and then we have our equation. So what's it going to be? Tan of 36 times 4, 2.91 meters. Now, you know, I'm rounding pretty cavalier here. So we can put all these in. We've got 4.94, and we now know that that is 2.91 meters. So we just check Pythagoras. Now Pythagoras says that this squared, let's call it a, plus that squared equals that squared. So if I want to get this hypotenuse, it'll be that squared plus that squared, all square rooted. If I punch them in, I've got 4 squared plus 2.91 squared, and hopefully that comes to 4.94. And it sort of does, yeah, 4.94. I mean, it's not exactly, but it's pretty close. So, trig works, Pythag works. Happy days. Let's do another one, eh? 56 degrees and 80 meters. Okay, so again, just look at what you got. And see what you ain't got. So, first off, label it. It's my opposite, because the eyeball's looking opposite. This is my adjacent, and slopey side is always the hypotenuse. So in this case, I've got the hypotenuse. So I can I use sine? I can use sine to get my opposite. I can use cos to get my adjacent. Can't really do anything with tan because I've got 2 unknowns there. So tan's out the equation, and I'm left with a choice. Do I work out my adjacent first or my opposite first? And again, it doesn't matter, you choose. What should we do? We haven't touched sine, so let's do that first. So it'd be sine of 56 is equal to the opposite, which we don't know, divided by the hypotenuse, which we do know. Same transposition as we did a minute ago with cos, but it'd be times 80 cancel. Sine of 56 is equal to times 80 equal to opposite, but oh yeah, we're done. Oh cool. So that's our equation. So our opposite then is 66.3 meters. And then we can use cos to use the adjacent, or now we could probably use Pythagoras to get adjacent. You know, that's what I love about triangles. You've always got like loads of different options, and as long as your accuracy is good, you don't wildly round up like I tend to do, you'll be good. So I'll use cos again because, yeah, why not? Sorry, cos of 56 is equal to our adjacent, which we don't know, over 80 meters. So multiply that out, that goes over there, and we're left with our, we'll cancel that out, and we're left with our equation, 6. So a bit easier, that transposition. 80 times cos 56, 44.74, oh god, rescued, meters. Happy days. Last one then. Let's say we want to know the height of a building. I don't know. Do a bit of applied. But we know that angle because we've got very expensive theodolite on site for some reason, and we could measure that quite easily. So if I abbreviate these to remind us, Which one can we use? Let's put an angle in here. Let's say it's 60 degrees. Well, we want this, which stands for height here, which in this case is our opposite. And we can get this adjacent, let's say we paste it out at 18 meters. So, you know, it lends itself to using tan here and rearranging for this opposite, because that's the opposite. And that's the adjacent, and slopey side is always a height. So, what we're saying is tan of 60 is equal to the opposite, which we're after, divided by our adjacent of 18 meters. Same transposition again, really, isn't it? 18 meters, multiply that out, copy it that side, cancel. So 18 times tan of 60 gives us our opposite, which in this case is our height. So 31.2 meters. So let me just get a bit of perspective on that. So 60 degrees, about like that. Yeah, and 18 meters, yeah, I can see that. Be about 30, so double it really, isn't it? Yeah, that works. Now, last thing I just want to go over really is our power triangles in electrics, because this is where you're going to be using it, and your impedance triangles and your voltage, and you've got current triangles. Watts. And with all of them, I've got a common parameter, haven't they? We're always after this angle, and we say power factor is equal to resistance over impedance, and we say power factor is equal to watts over VA, and we say power factor is equal to VR over VS, and we say power factor is equal to IR over IS. And just notice that what are these all the time? Well, we've got this angle's the one we've got. This is the power factor angle. So we've got our adjacent and we've got our hypotenuse. And power factor is a number between 0 and 1, which is the cosine of the angle. Here, well, we've got the same thing again, haven't we? We've got adjacent, hype, adjacent, hype. So it's just trig in disguise. And that's kind of what I wanted to say, really. And the other thing about these triangles is that, you know, resistive part of the circuit goes with watts. That goes with the volts dropped over any resistor in the circuit. You're talking about the current through the resistor. These positions are all kind of the same. And so that's something to really kind of get your head around. This video is about trig, so I'm not going to divert into power stuff. But there we go. I think that's probably enough to give my students some thinking. Next video on trig, I will do how to get the angles.